Hello. Okay, so we have an interesting topic today, which is the match control flow in Rust. It goes this way. You type in the match keyword and then you open curly braces. Beside this match keyword, you type in what you want to match. Okay, let's just say X here, and let's create a variable X that we assign to 3. Now, if you come from other languages, the match control flow is more like a switch statement, okay, but it's actually more powerful than a switch statement because it's also an expression. I'm going to explain that in a second. Now, by just doing this, Rust will say ensure that all possible cases are being handled by adding a match arm with a wildcard pattern as shown here, which is exactly what it wants us to do. Now, what you can do here is we want to say this X will be different values at different points. So in this case, let's say we want, this is a dice, okay, and you know that a dice can be from 1 to 6, and I want to print whatever it is. So if it is 3, we print something in here. So what we can do is we match dice against several scenarios. The first one will be when it is 1, okay, because we don't have 0 in dice. When it is 1, we want to print something to the terminal, okay, and you can see that even after providing the first arm, every scenario we compare is called an arm inside the match. Okay, we've compared the first one, but Rust is letting us know that since this dice is an integer of I32, it could be anything. It could be 1, it could be 2, it could be 3, continuously till the maximum value I32 can hold. So we need to handle other cases as well. So what we do is we use this underscore. This is a way of saying for every other case, print others. And now Rust is happy. So this underscore represents the default value for other scenarios. Just like in switch statement in other languages, you have the default arm of a switch statement. That is exactly what we are doing here. We say when it is 1, we want to print 1, but for all other cases, print this. And you can see what will happen when we run that code. You can see that it says others because the dice has the value of 3 at this point. Now if we change it back to 1 and run that code, we get 1. Okay, so it functions similar to if statement, but it has more powers. Now, of course, it can be 2. You can add other arms here. Here we say 2, and if the value is 2 here, if we run that code, of course we get 2. So you get the idea. The major difference between a match control flow and an if expression is that if expression, the conditional value must evaluate to true. Okay, if you have an if statement here, dice, you can't just compare if dice will be anything. You have to compare if dice is exactly equal to something. So the conditional statement must amount to a Boolean value before it will work. If it is true, it will execute the code. But match is a lot more powerful and can allow us to achieve more. And then going further in the example, we can even use a range of value. So for example, we can say for 3, or using this bar for 3 or 4 or 5, okay, print 3 to 5, and watch what will happen. By the way, pay attention that each arm is separated with a comma and not a semicolon. This can be very confusing in Rust. Okay, in many other languages, every single thing is separated by semicolons, except arrays that has their values separated by commas. But here in Rust, each match arm is separated by a comma. Okay, the same thing with struct fields and so on, even enum variants. Now, if you run this code, let's say we make the value 4. And then run that code, you see we get 3 to 5. So this is valid. Okay, now you can even use range in Rust. You can say from 6, you use this double period sign. You can say from 6 to 10, okay, print something else. You can say it's 6 to 10. Now, when you do this, even though this is a valid syntax, but it is still experimental in Rust. You see, you can see that Rust is saying exclusive range pattern syntax. It's experimental. Okay, you can check out the issue in GitHub. We are still debating that out. But you can use inclusive range pattern. Okay, and Rust will accept that. And if we run that code, you get, oh, we have to change this to 6 to 10. Let's just set it to 7. Now we get it is 6 to 10. So inclusive range really works. Now pay attention to what we did here. In Rust, you have exclusive range and inclusive range. Okay, if you remove this equal to sign and leave the double dot, it will be an exclusive range. But if you do this, it will be an inclusive range, which includes 6 to 10. Okay. Okay. But of course, you can see that Rust is warning us. Okay. Because exclusive range patterns are still experimental. Okay. You can use exclusive range with for statement, but for patterns, it's still experimental. So we have to use inclusive range. Okay. So the difference is that exclusive range will start from 6 and then we end before 10, 6 to 9. But inclusive range will start from 6 to 10. It will also include the right one, which is 10. And you can see that, in fact, if we set this to 10, and when you run the code, you see it is 6 to 10, which means 10 is also included. Now, as you can see, we've provided single values as the conditions. We've also provided values separated by the bars, which will match either of them. And we've also provided a range as the condition. And then this will signify the other case scenarios. Now, it's not just int types. You can also match Boolean values. For example, let's say we have a variable that holds the day of the week. Okay, if it is Friday, it will hold true. It will hold false. You can also match that and then say when it is true, then do something. Okay, you can say yes, it is Friday. But what will happen? Rust will underline this code. Okay, it will say missing match arm false. So it has detected that we just provided the case for true. We also need to provide that of false because it's possible that this might be false at some time. This way it prevents you from compiling code that could result to an error later on. Okay, so you have to provide that value. Of course, you type the name, what you are comparing, and then the value. Now, if you have more code to write, you can also open a new scope and write the code in there. Okay. Now, when we run that code, you see that it will say yes, it is Friday because this value which you are comparing holds true. However, if you change it to false and then run it again, it will say it is not Friday. So you can compare anything here. Now, another thing I need to point out is this. This match conditional flow is also an expression. And as you know, as expression in Rust, which I've explained in detail in this video that you'll see pop up at the right, I explained the differences and the similarities between statements and expression in Rust in detail, so you can check it out as well. So here, a match control flow is also an expression, which means it returns a value. Okay, for example, let's say here we want to return a message which we can then print out later on. You can say message is equal to that, and then we provide a message. Now you can see that right now Rust is saying that this expression, this match expression, is going to return a unit, which is an empty tuple, which is like saying it will return void. But once you start providing what it will return, then it will know the type. Let's say we want to return a string. You can say Friday, and then it has turned it directly. You can see right here that the Rust compiler has detected that it will now be a string. Okay, you can even convert it to a string object, and it will now convert it back, recognize it as a string object, and it will now start demanding that we also return a string for this arm. Watch what will happen if we decide to return something else. Let's say let's remove this scope. Let's say if we decide to return an int here, it will highlight it and then it will say try using a conversion method dot to string to convert it to string. So right now it is still requiring for a string, so we can then change it to not Friday, and then we'll convert it to a string. So we now have, now when we run this code, this message will hold whatever it is that was returned here. So if this value is Friday holds true, then this message will be returned and stored inside this variable. The same thing if this was false, this message will also be returned and stored in the inside the message variable. And you can see that when we run this code, we say not Friday message is equal to not Friday, which means this is what was returned. So the match control flow itself is also an expression because it returns some value. Now, in most cases in Rust, you will see the match control flow used regularly for enums. Okay, and that is one thing that one of the most powerful features in Rust. We've already explained in detail how enums work in Rust. You can check out the video by the right hand side where we took a look at enums and how to use them, how they are similar to struct in many ways and even tuples. Now, okay, let's say we have a contract to write a Rust program that will calculate the amount a jewelry is worth. Okay, and the jewelries could be of 4 types: gold, silver, diamond, and copper. So for gold, each jewelry is worth $15. For silver, each jewelry is worth $10. For diamond, each jewelry is worth $50. And then for copper, if there are jewelries made of copper, each kilogram is worth $5. So there are many ways we could approach this code, but one of the ways we could do that is, since we have this a predefined variance, okay, it could be of 4 types. It could define an enum to hold those variants. Okay, we can say enum, we have gold, we have silver, we have diamond, and we have copper, and then let's just call it jewelry kind. Now we have an enum with 4 variants, each of which could represent each of these gold. But since we know the prices and we know that each of them has a particular price, we want to make it easy for whoever is, let's say we are writing a code and we have a, let's say, copper jewelry which will hold 4 to 5 kilograms, okay, and we want to know the price. Now what we could do is to create each of these variants to accept an amount. Okay, we could say each of them, let's start with gold, each of them will accept a value of type F64. Okay, and then let's say for gold, let's say this is gold, a gold jewelry that has, okay, let's say the gold variant will accept kilograms. Okay, and then here we will say it will accept F64 values. So whenever you're using the gold variant, you have to provide the amount of the kilogram of the gold, which is exactly what we can do here. Okay, we can then say this will be a jewel kind, and then we accept the gold, okay, using this double colon right here, and then we provide the value in kg, which will be 45.5 here. Now if we want to know the price, it will be a lot easier for us to call gold jewelry, and then we say get price. Okay, so in order to do this, we can now create a method for this dual kind that will return value. As we explained in the previous values, enums can also have methods just like structs, and in order to do that, you use the implementation keyword, and then you say that the dual kind, let's just copy that. You say that the dual kind can have a method. You can now create a method inside there. Let's just call it get price. Okay, and for whoever is calling this, we need to make it a method so that it can be called. And in order to make it a method, we pass this self value here. Okay, this will make this function a method. So this self will represent the instance of this dual that we are using when we are accessing this, and that will be exactly this variable at that point because we've instantiated this enum here. Now what we need to do is to return the price, and we know that each gold jewelry of 1 kilogram costs $15. So what we can now do is to return, okay, we also have to accept the value here. Let's just say kg, which will be of type F64, and we can now say 15, which is what 1 kilogram of gold costs. Okay, now each variant of this dual kind will accept a kilogram. Now inside here we have to calculate the price and return the values. Okay, I will know that each of these will have that price. Each of these have their own price for each kilogram. So what we can do here is to use the match control flow expression to return the values. Okay, we can still say return, and then we use the match expression, and what we want to match is the self value, which will represent the instance of dual kind at that point. Okay, and then we know that there will be different variants of this. It could be gold, it could be silver, it could be diamond, or it could be copper. Let's focus on gold for now. Okay, now we have to specify that this function will return a float. Okay, let's say it will return F64, and why that is important is because since it will return the price, you can have $10.4. You can have, so the decimal might be there. So the first thing we do is we match the gold variant. Okay, so we say self gold, and remember, pay attention that we are using a capital S here to represent the self. This will represent the instance of this variable. Okay, and then we say when it is gold, and since this particular gold variant will accept a value of F64, let's also provide it here. Okay, and then we can do something inside this block of code. We separate that with a comma. All we want to do is to return the value. In fact, we can do that in just one line. Okay, and remove that new scope. What we have to do here is to say for gold it will be $15. Okay, 0.0, and then we multiply it by the kg. Okay, and that will return the value, the price. So kg is this variable, y15 is the price for gold. Now let's do the same thing for silver, diamond, and copper. Okay, so now we've provided the arm for silver, diamond, and copper. So essentially what we are doing here in a nutshell is we're saying when you call this method that is inside this dual kind enum, and it's a method because it accepts the self variable, which will represent this instance of this variable. We then use a match statement, okay, a match control flow expression, and return whatever match returns, which is the value that we will return for each arm. And then we'll compare all the possible values that dual kind could have. It could have gold, it could have silver, it could have diamond, it could have copper. Then each of these arm will return different values. Pay attention that the value each arm will return must match other values. Okay, they must match for us to return the same thing as F64. For example, you can't have whatever this one, let's say we can have this one, for example, return a string. It's not going to work. Rust will start warning us immediately, and if you scroll to the error, it will say match arm have incompatible types, expected F64. So each arm must return the same type of value. Okay, so now all of a sudden we now have a method that returns the accurate price. And so testing time, let's test it out and see. So here we also have a silver jewelry. And remember that for each of these values we must use the corresponding variant. So we say that one will be for silver, this one will be for diamond, and then this one will be for copper. Now let's start printing their prices to see if they will be correct. In fact, let's make it a lot easier by reducing the values. So let's say 4.0 here, this one will be 5.0, this one will be 6.0, and this one will be 10.0, 10.0. Okay, now let's print them to the terminal to see what they will hold. You can also do some debugging here, but let's print them to the terminal. So now we've printed all of them to the terminal. For gold, for silver, we use the corresponding variables to get their prices. So let's run the code and see what will happen. And then it says gold is equal to 60. Let's find out if that is correct. So for gold jewelry, we have 4.0 kg. The price for 1 kg will be $15. So 15 times 4 will be 60. So that is correct. For silver, the same thing. Each one is worth $10, and we have 5 kg. So 5 kg times 10 is equal to 50. The same thing for diamond. Each kg is worth $50, and then we'll have 6 of them. So 6 times 50 is 300. The same thing for copper, $5 for each kg, and we have 10 kg. 10 times 5 will be $50. So this makes sense. As you can see, the approach we took, we used an enum to create all the possible variants, which will be gold, silver, diamond, and copper. And then we created a method on that enum called getPrice. Okay, we made it a method by using this self value. I explained in the previous video, which you can check out right here, that explained why and how the enums method work. Okay, this is actually brilliant what Rust does here, because this will, if Rust did not have methods, the feature for methods, or if Rust did not provide the ability for us to use methods in enums, we would have to create another struct, okay, just to manage this getting of price and all that. But since we have the ability to use methods in enums, we are able to do that here. And then to compare what the variants are, because they will have different variants, we use the match control expression, and we'll return whatever it is this match returns, because it's an expression that returns a value. Check out this video where I explained expressions and statements and what their differences and how they work. Okay, so this match control flow is an expression, and whatever it returns is what we are going to return here. And Rust is smart enough to make sure that since you are returning whatever match it returns, okay, that this method that we've defined to return F64 must match what each arm will return. As you can see before, when we try to return string for each of these arms, it starts warning us. And also pay attention that inside this match expression, we use the self we use self with double colon gold to access each of this arm. Okay, this self must be capital letter, so pay attention to that. And it's different from this self that we have here. It's not this that we are using. Okay, we are accessing it directly. It's like accessing an associated function. in a Rust, or in other language, in a struct, or in other languages, when you accept, like in PHP, when you access a static method, okay, or prompt, you usually use this double colon, okay, and then since each of these variants accepts a value as well, we will then read those values they accept here, and then we can then return something. Okay, if we had more code, what we are doing here is equivalent to having a block of code here. So if your code will span many lines, you can just add a new scope by using these curly braces, and whatever I return there will still be equivalent to returning something from other arms that doesn't have these curly braces. So I hope this goes to explain how you can achieve certain things in Rust. Okay, in the comment section, leave any question you might have. If you need some feature clarified in Rust, do let me know so I can put that into consideration while making new videos. So thank you. Remember to like the video as it helps me out a lot, and subscribe so you get notified when we release new videos, as we release new videos every day on this channel. So thank you.